we are going to learn about graphing parabolas using the vertex form. So one thing that we want to look at and evaluate and sort of determine is, here's a new, let's take this equation, copy it. Here's a new form that you're not necessarily familiar with. We are familiar with standard form. So the question really is, how would we graph this? If we had to graph this and we had no idea what to do, what are some of the techniques that we could use in order to maybe graph it? Well, the first thing is we could put it in an H chart. And we can pick values of x. We could pick 0 and plug it in. We could plug in 1 and plug in -1. But we need to remember, what is our concern about that? Well, our concern is we don't know where those points are on the graph. So if we have a graph, we don't know that if we plot this, if we get a point here, -1, 0, we don't know what this chart does. Does it go this way? Does it go this way? Does it keep going down way down here? So what are we looking for? We don't see the vertex. Where's the vertex? So the vertex is really a key important point to be starting, because we know that it's going to change its shape at the vertex. It's either going to be at the bottom or it's going to be at the top. So we don't know anything about this graph. So that's why we tend not to plug in just any random point. We actually want to have some understanding of why we are plugging in these points. So we wouldn't use the H chart to help us. The other way that we could do this is, wow, well, okay, if this is vertex form, what if I converted it into standard form? So I would simplify this, and we need to remember that this does not equal x squared plus 1. You do not distribute that to both of them. You can't distribute exponents across addition or subtraction. What this really does equal is this equals the quantity of x plus 1 times the quantity of x plus 1. We have two of them. That's why the exponent is 2. And now we would use FOIL, first, outer, inner, last, and we would distribute, and we'd get x squared plus 2x plus 1. And my hopes is that you are able to do that mentally. We should, whenever our x's have a coefficient of 1, we can do FOIL mentally. So that'll go into that equation. So now it becomes y equals x squared plus 2x plus 1 minus 2. So we filled in this for this piece, all right? And now we can combine like terms here. We have +1 and -2. So we can continue to simplify. We get y equals x squared plus 2x minus 1. Now that's in standard form. However, we had to do a lot of work, and that really doesn't take advantage of it starting in vertex form. That should be something that we should actually embrace. So let's talk about what characteristics, when an equation is in standard form, what can we derive from that? So if we graph this y equals x, quantity of x plus 1 squared minus 2, what we are able to do is we are able to find its vertex. If we look here, we see that the vertex is going to be -1, -2. So, how was I able to look at this equation, and how was I able to pull out that information? So what characteristics? Well, we see that the x value is -1, right? It's -1. That's the x value of the vertex. And we see inside these parentheses, we have a +1. So this form is in y equals the quantity x minus h to the second plus k, where h equals the x value. So notice it's shown as the opposite of h in here, this is the opposite of h. So if I want h, I need to do the opposite of what I see. So my x value is going to be -1, and then that my y value, designated as k, will be whatever is being added or subtracted. So we notice that that's -2. So if I want to find the vertex, I'm going to do the opposite of the constant inside the parentheses, and then I'm going to take this as my y value. And we cannot find the y-intercept at this point. We can't find out any point. All we can derive from vertex form is the vertex, which isn't bad. So let's take an example. So if I give you y equals the quantity of x plus 6, quantity squared, let's make sure that looks like a 6, minus 8. So what would the vertex be? So we're looking for an x and a y value. So the first thing I need to know is that I'm going to take the opposite of what I see. So I see a positive 6, and my x value would be the opposite of that. And then my y value is going to be whatever I see. So that would be my vertex. And once we get that, that really helps us. That sets everything up for all the adjacent points. So this is a nice, easy way of finding the vertex. In fact, the vertex form is a little bit easier. Remember when we wanted to find the vertex, we had to do the opposite of b over 2a and plug that in. And sometimes we got fractions and all that other stuff. These are typically all whole numbers. So let's try one out. So we have this equation, y equals the quantity of x minus 3 squared minus 5. So the first thing we want to do is we want to find the vertex. So we know the vertex is going to be the opposite of that value. So if I see -3, I know my vertex is going to be the opposite of -3. It's going to be +3. And then I know that my y value is going to be whatever is being added or subtracted to the quantity. So I have a -5, and that would be my y value. Now we're going to plot that. We're going to graph it. So let's make this a little bit smaller. So 3, -5. 1, 2, 3 on the x, -5 on the y-axis. All right, so there's my vertex. I'm going to label it because I always label points after I graph it. 3, -5. What do we also know? So it wants us to plot the axis of symmetry. And what do we know about the axis of symmetry? Well, the axis of symmetry also lies on the same vertical line as the vertex. So we know that we're going to mirror points across that axis. So that's nice. So we're good with the axis of symmetry. Y-intercept. Okay. So what piece of information do we know about the y-intercept? Let's go back to this example. We notice that this point right here is the y-intercept. Any point on the y-axis is going to be considered the y-intercept. So of these two values, what do we always know about y-intercepts? That my x value is always going to be 0 because that's what places it on the y-axis. So when I find my y-intercept, I'm going to plug in a 0 for x. So I'm going to take this equation, y equals the quantity x minus 3, quantity squared, minus 5, and I'm going to plug in 0 for x. And I'm going to simplify. All right, that's, oh, where am I? There. I hate how we can't move the page without moving. All right. We have exponents, we have grouping symbols, so we're going to do what's inside the parentheses. 0 minus 3 is -3. And now we're going to square -3. -3 times -3 is 9. 9 minus 5 equals 4. So when I plugged in a 0, I got +4. So I plugged in 0. We notice this. Let's highlight that. So we're going to plug in 0 for x. There's my x. I plugged in 0. And when I plugged in 0, I got 4 for y. So that gives me my coordinate. So let's highlight that. So we have 0, 4 as a point. That's good. Let's label it. So that coordinate is 0, 4. Now how about there? Yes. All right. Now we want to mirror it. So what is the distance of my y-intercept to my axis of symmetry? How many spaces? That's 1, 2, 3 spaces. So I'm going to go 1, 2, 3 spaces out on the same vertical location. So that would be right. Oh, do you see that? That just somehow turned purple. I don't know how that or why it turned purple. All right, let's get rid of these things, these arrows. So now I have graphed my y-intercept. I've also graphed my mirror point. And now let's see what is that location. This location is not based upon the axis of symmetry. It is based upon the origin. So where is this point? Where is this point based upon my origin? Where is it on the x? It's at 6. Where is it on the y? 4. So that coordinate is 6, 4. Now we have 3 points. I need a 4th point. So I need to pick an x value. What x values have I already used? I've already used 0, I've used 3, and I used 6. So I need to pick some other x value. Other than that, I'm going to choose the easiest, and I've already mirrored my y-intercept. Now I'm picking my 4th point. I'm going to pick x equals 1. Let's keep it easy. Keep it simple, as they say. All right, so that would be y equals the quantity of 1 minus 3 squared minus 5. Let's continue to do orders of operations. 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus 5 is negative 1. So when I plugged in 1 for x, I got negative 1 for y. So let's graph that point on the chart. So we plugged in a 1 and we got a negative 1. So let's use my highlighter. So plug in 1, I got negative 1. That would be that location. It is 2 spaces away, so I'm going to make its mirror point there. And now I'm going to label those points. So I know that that point was 1, negative 1, and this point is going to be 5, negative 1. I have 5 points, and now I can connect them with arrows. I have 5 points. I have my 5 coordinates, and then I have my parabola with arrows. Remember that the 5 points need to consist of the vertex, the y-intercept, its mirror, and then a 4th and a 5th point. So hopefully that made sense, and hopefully that makes sense, and you're getting a little bit, you understand how that's going to work. Here we go. I found out a way to move the screen. Okay, so let's try 1. I want you to try this by yourself. Take a moment, pause it. Hopefully you took down the 6 steps that you would use. And then after you've graphed it, labeled your points, you can unpause the video and see if you got it correct. All right, so hopefully you have your graph. So the first thing that we're always going to do is we're going to graph the vertex. The vertex in this situation is going to be negative 2, negative 4. It's the opposite of this value for the x, and it is what you see for the y. So I'm going to plot that. Negative 2, negative 4 takes me to this coordinate. Negative 2, negative 4. Now, part 2 is to draw the axis of symmetry. We need the axis of symmetry because this is what we're going to reflect our points across. So very important. So we drew our axis of symmetry. Our next thing is going to be find the y-intercept. We need to remember that when you find the y-intercept, you plug in 0 for x. So we take the equation y equals x plus 2 quantity squared minus 4, and we're going to plug in a 0 for x, and then we're going to simplify. So 0 plus 2 is 2, 2 squared is 4, 4 minus 4 is 0. So the x-intercept is actually going to be 0, 0. That's interesting, right? You don't see that often, but it does happen, where the origin can be your y-intercept. Now that is 2 away on the right, so I'm going to go 2 away on the left. And that location is negative 4, 0. Make sure that you labeled it negative 4, 0 and not 0, negative 4. X values first, then y. All right, so we have done the mirror. Step 4 is mirror the y-intercept. We've already done that. Step 5, oh, here we go. Step 5 is going to be find a fourth point. So we have to pick another x. What x values have we used up until this point? We use 0, negative 2, and negative 4. So logically, you would want to use 1 as your x value. So let's plug it into the equation. The equation, again, is, x plus 2 minus 4. X plus 2 squared minus 4. So when we plug in a 1, we get y equals the quantity of 1 plus 2 quantity squared minus 4. 1 plus 2 is 3. 3 squared is 9. And we get y equals 5. So when I plugged in 1, I got 5. That is going to be my fourth point. So I go back to my graph. X is 1, y is 5, takes me here, 1, 5. It is 1, 2, 3 spaces away from the axis of symmetry. And now I'm going to go 3 places to the left. And that would give me, now I have to go back to the origin to find its location. That's negative 5 on the x, that's positive 5 on the y. So that coordinate is negative 5, 5. I have my vertex, I have my y-intercept, I have the mirror of the y-intercept, and I have a fourth and a fifth point. So I'm going to connect those. I'm going to draw arrows on them, and I am good to go. Those are the things. Everybody's going to have the same vertex. Everybody's going to have the same y-intercept. Everybody's going to have the same mirror of the y-intercept. Now, people may differ from their fourth and fifth points. So how am I going to grade that? Well, I'm going to grade that by looking at your work. And I would expect to see something like this right here as your work. Show your work. Show your work and be organized. Because you're conveying information, I have to grade you on it. If there is a point that doesn't coincide, I'm going to need to look at your work and see whether you understand it or whether you are guessing. All right, let's look at this. What do we notice about this equation that might be a little bit different from the others? Hopefully, when you look at that, you notice that there is a negative outside of the quantity. And since there is a negative outside the quantity, we should know that this graph is going to be upside down. When your coefficient is negative, we know that it's going to be an upside down U. Okay? So we still pull the vertex the same way. The vertex is still the opposite of what we see there and what we see there. So that still stays the same. Don't change anything else. All you're looking at, all this does, this negative outside, just tells you the shape of it. So the vertex is going to be 1, 2, 1 on the x, 2 on the y. We're going to make that, we're going to label that point. We have the axis of symmetry. So the axis of symmetry is going to be where x equals 1. We're going to find the y-intercept. Y-intercept, we're going to plug in 0 for x. So we take this equation, y equals the opposite of 0 minus 1 quantity squared plus 2. Now, orders of operations, we still have to simplify what's inside the parentheses. Now, we have these two negatives. Oh, look at that. Didn't stop. We have these two negatives. We have this negative and this negative. We are not going to simplify that yet. We have to do the exponent. When we combine two negatives, that's multiplication. That operation that we're utilizing is multiplication. So we have to do this exponent. The base of this exponent is negative 1. So we have negative 1 squared, which equals 1. And now we're going to bring down this negative because it's outside of it. So we need to understand that this 1 represents negative 1 squared, and then the negative off of it is coming from being pulled down here. And then we have plus 2. So that leaves me with y equals 1. So when we plugged in 0, we got 1. That would be my y-intercept. 0, 1. It is 1 away, so I'm going to reflect that point. Let's do this. I'm just moving this up. So if we reflect this point right here, it's 1 away, so its reflection point is going to be there. What is that coordinate? That coordinate is 2, 1. Now we have to find a fourth point. So let's go, and 4 was mirror y-intercept. Step 5 is fourth point. So what x values have we used? We've used 0, 1, and 2. So I can use negative 1 or I can use 3. I'm going to use 3. I'm okay with that, right? We can still be able to do these math problems. So we get y equals the opposite of 3 minus 2. Oh, excuse me, 3 minus 1. 3 minus 1 quantity squared plus 2. Remember, I'm getting it from up here. I'm just using this equation when I plug in a new value for x. So I'm not getting it from random places. I'm getting it from a specific place. So let's simplify. 3 minus 1 is 2. We're going to square 2, which is 4, and then we're going to pull down that negative, and we get y equals negative 2. So when I plugged in 3, right, here's my 3. When I plugged in 3, I got negative 2. So let's go up, plot that point. 3, negative 2. All right, right there. 3, negative 2. That is 2 away, so I'm going to count 1, 2 to the left. And that point is negative 1, negative 2. I've got 5 points. I'm feeling pretty good about my graph. It is the shape that I was expecting. Remember, we had a negative coefficient outside of that parentheses. So I kind of knew, I knew it was going to be upside down. Ooh, now we have a fraction outside. Yowzers. So, does it change anything? Nope. The vertex is still going to be 3, negative 5. 3 on the x, negative 5 on the y. I know since the number outside of the parentheses is positive, I know that I'm going to have a U-shaped because that is that way. All right, that coordinate is 3, negative 5. Axis of symmetry. So the axis of symmetry is going to be the vertical line going through my vertex. I'm going to find my y-intercept by plugging in 0 in for x. I get y equals 1/4 times 0 minus 3 squared minus 5. Ooh, that's going to be ugly. Y equals 1/4 negative 3 squared minus 5. Negative 3 squared is 9. This is why we need to know our fractions. 1/4 times 9. 9 over 4 minus 5. All right, now we have fractions in a whole number, so I need to convert 5 to fourths. How many fourths is equivalent to 5? 20. 9 minus 20 gives us negative 11 fourths. What is that as a mixed number? That is 3, Mr. Mac, 2 and 3/4. Negative 2 and 3/4. So when I plugged in 0, I got negative 2 and 3/4. Woo, baby. 0, negative 2 and 3/4 is right there. It is not here. That would be 1/4. We go away, we're getting bigger. So negative 2, negative 2 and 3/4, negative 3, negative 4. So that location is there, and we label it 0, negative 2 and 3/4. Mirror point, 1, 2, 3 away from the axis of symmetry. Missing a couple dots there. So I'm going to go 1, 2, 3, and that coordinate is 6, negative 2 and 3/4. All right, now here we go. What is going to be a good number to plug in here? What's going to give me a nice one that maybe won't be a fraction? Could you do 1? Sure, you can plug 1 in there, and that's going to produce a good number. Remember, we might want to think about how whatever comes out of here can cancel with that denominator. So whatever we plug into here and simplify and then square, is it going to be a multiple of 4? Can it be simplified? So in this case, we get lucky because most of you are going to want to pick 1, which is good. You should absolutely pick 1. So if we pick 1, so step 4 was mirror, which we already did. And step 5 is the 4th point. So we picked 1. So if I plug that in, I get y equals 1/4 times the quantity, 1 minus 3 quantity squared minus 5. I think it was minus 5. Yes, minus 5. So now let's simplify it. We get y equals 1/4. 1 minus 3 is negative 2. Negative 2 squared is 4. Oh, look at that. Now you maybe see what I was talking about. You see that this simplifies because we have in the numerator, the 4, and the 4 in the denominator are going to be able to cancel. So 1/4 times 4 is 1, minus 5 gives us 4. Negative 4, excuse me. So when we plug in 1, we get negative 4. Let's graph that. 1, negative 4. 1, negative 4 is right here. Whoa, how cool is that? This is our first fat one. Notice it's not as sharp up and down. It's actually a little bit wider. So that's 2 away. Let's make that 2 on the right. And that would take us to 5, comma, negative 4. So we have our 5 points. Let's graph it up. And we know that it's going to be a little bit more open. So we connect those dots and we get that. So that's a real good problem. Hopefully you understood how that coefficient is affecting the shape of the parabola. And the last one. So I'm going to let you again. I'm going to take a second, and I want you to do all those steps, and then pause the video. And once you're ready, I want you to unpause it, and I'll go through the solutions. So pause the video now, and then unpause it when you're ready. The vertex is going to be 1, comma, negative 1. 1 on the x, negative 1 on the y. It is going to be upside down because coefficient is negative 2. So we have 1, negative 1. My axis of symmetry is going to be where x is 1. My y-intercept x equals 0, I'm going to get y equals negative 2 times the quantity 0 minus 1 squared minus 1. That gives me negative 2 times negative 1 squared minus 1. That gives me negative 2 times 1 minus 1. That gives me negative 2 minus 1. And that gives me negative 3. So when I plug in a 0, I get negative 3. Does that work with what I was expecting? I was expecting it to be upside down. Does this continue with that story? Yes, it does. We're going to reflect it, and we get 2, negative 3. So those are 3 points that everybody should have. 4 is mirror. Now we're going to do 5 is pick a 4th point. So I have used 0, 1, and 2. I'll use 3. Let's plug in 3 into the equation. Y equals negative 2 times 3 minus 1 squared minus 1. Let's simplify that. 3 minus 1 is 2 squared minus 1. We're going to square 2, which is 4. Now we're going to multiply negative 2 times 4 is negative 8. And negative 8 minus 1 is negative 9. So when we plugged in 3, we got negative 9. That's my 4th point, 3, negative 9. 3 on the x, negative 9. Oh, that's not negative 9. Negative 9 is right here. So that is 3, negative 9. Its mirror point, it is 2 away. So I'm going to go 2 in the other direction. That takes me to negative 1, negative 9. I have 5 points. And here is my graph. Pretty sure that's it. Nice. Come and see me if you have questions. You all have done a great job in class, so I would expect you to continue to excel in this. Nice job.